Servo motor is a motor that can control the position or the angle it's on the gear, and you can maintain the position even there is someone artificial load or outside interference. The application of motor servo basically used in robot arm, robot humanoid, robot animal, or setting in RC car. Basically, on motor servo, you can choose a two mode. The first one is open loop that make a robot rotate in 360 degrees. And the second one is closed loop that you can make robot rotate in 118 degrees.
Specification of motor servo. In order to choose the right motor servo for your project, you need to know the specification. And here you can see the sticker, some sort of sticker, and there is written micro servo 9G. It means that this motor servo can apply about 9 gram, and the 9 gram is not all in the arm of the servo arm. It's basically on this one. It's the 9 gram. But while it's far, the more distant the weight from the center of the motor, it will decrease the power. Like in here, it decreases to 9 gram, and so on. Until it's 0, it can leave nothing. The specification for this motor is weight. It can hold a weight about 9 gram. The dimension is 22.2 times 11.8 times 31 millimeters approx. The stall torque is how much weight this motor can hold until explode. Yes, we can say it like that, until it explodes or it's burning. You can see here it's 1.8 kilogram. Operating speed is 0.1 second per 90 degree, and operating voltage is about 4.8 volt, or we can categorize as 5 volt. The design of servo. You can see there's a design of servo in here. It is the first. It included so many gears in it to make it more powerful. I want to divide it by 1, 2, 3, 4, 5, 6, 7, 8. 8 gear. So the first one connected to the second one, and the second one connected to the third one. It's actually one gear, but it's different size, so I make it 2. And the third one connected to the fourth connected to the 5, the 5 connected to the 6, the 6 connected to the 7, the 7 connected to the 8, and the 8 produce the output. So why do we need so much gear for this motor, for this kind of motor? It makes is low torque and high speed, and the output is high torque and low speed. So what we want to use motor servo is what we want to make a precise angle for a motor to turn. Like I want to turn the motor about 90 degrees, and we program it, we turn it to 90 degree angle. But it is so hard to make it without a gear, and it is so hard to maintain the speed of the motor. So sometimes if you're using the usual DC motor, it will not as good as servo motor. And also the high torque make it more powerful. I mean it has more power to lift something. And this is the inside of the motor servo. servo motor, there is a motor, there is the DC motor, as usual DC motor, the circuit board that attached to the DC motor to control it whether it's going to turn left or turn right, and the potentiometer. This is this is giving a feedback loop to the PCB to measure how much is the motor has turned. And if we want to use motor servo, we need to know the wiring of the motor servo motor in order to not making it explode or something burn or something smell burning. Here is the wiring of the servo motor. As you can see, the VCC of the servo motor connected to the 5 volt in the Arduino, and the ground connected to the ground in Arduino, and the signal pin is connected to the 9 pin in the Arduino. Make sure you connect it to the digital PWM, because this is a servo motor. The output is not 0 and 1. The output is sometimes 100 and 180, 19, 60 or else. So you need to make the pin to digital PWM. Basically, it's has the minus thing in under near it, like minus 10, minus 11, minus 10, minus 9, something like that. And if you want to, well, just you don't want to make the degree is so precisely, like turning 180, turning 60, turning 90. When you do that, you need to change it in the program, but you're too lazy to change it in the program, so you need a controller. So I want to use a potentiometer. This is more simply like a volume temperature, but the volume like the volume one in the speaker, on your speaker or something else. The potential connected to the analog input, analog 0. In this case, I use analog 0. So we continue to the program. After you wiring, you need to program it. So we start the program from 0. When you start, you need to include servo.h. This is basically the library of the servo motor, and you declare servo as servo. You can name it my servo or servo 1, servo 2, yeah, whatever you like. So we set the global variable of position is in here, and when void setup, we attach the servo into 9 pin, so you can realize how I should give a voltage to the 9 pin. And in the void loop, we use for position 0. Position, as long as position 0, position move to 180, while by adding 1 by 1, and servo dot write pos delay 1, delay about 10. This is about 0.01 second. And for pos, for when position is 180, the motor will turn about back to 0, and by decreasing it 1 by 1. Servo right, pos the degree, the target. We delay it about 0.01 second. So what will happen in this program is the first position is 0. I mean, basically 0 is whether it's up or down or in the servo motor. we set and then we set the position to 180 by adding it one by one. Basically, is if the position is less than 80, turn it up, add it until it's 180. And the second one, if position is 180, turn it to decreasing it to 0 by decreasing it one by one. Basically, you can just put the 𝗕𝗲𝗿𝗃 and inside it this is the angle, like 60, 30 or 90, but I want to make it from back in time, like turning up and down. And the previous side we use the potential. So this is the potential one, the potential program. We connected to the analog 0 pin, and we serial begin to make it appear in the serial monitor, and attach servo pin. Servo pin is in a 9 pin number 9. And in the void loop we read the analog rate of potential integer angle map. So in here you can see you can see the program of map. Map in here is reading. Reading by mean is that reading is a target of the thing you want to control, and the first one is the current target, the current position of it is the current position of the potential, and this is the target position of the potential. This is the current position of the servo, and this is the target of the servo. And we print the angle, the degree, and the angle of the degree, and in from the angle of the degree in here. And then if you want to control the speed of the servo motor, you need to use this servo. My servo, declare it as my servo, and you add the moving time about 33 seconds and move start time. This is we use this as a start time, and the start angle, this is the current angle you use, about 30 degrees, and the stop angle is 90. So basically it moved from 30 to 90 degrees. It's about 60 degrees. And the void setup we attach like before, my servo.attach. Add the name of the servo, my servo, in here attach to the 9 pin. Then move start time is equal to millis. Millis is like converting your code, your pulse PWM code into millis code or second code. And in here the progress is like your current position and the target position you want to go. So the progress is minus move start time. The progress, if the progress is smaller than the moving time, and then the program should run this one, long angle map, the thing you want to control, the start time and the moving time. The moving time is the place you are currently at, and the start angle, the position you wanna go. Oh, and the stop angle, this is I mean the progress is the things you wanna control. And this is the start one. The start you want the current position of your servo, your arm servo. This is the target of your arm servo. This is the start angle, then this stop angle. And as usual, dot right to the angle. So that is the thing I want to show you. Oh yeah, after this I will show you the result of this program.
This is the first one result of the first code that can rotate in 160 degrees. You can see it, right? And when you touch or make a move with a potential, that motor can rotate in 118 degrees. And last but not least, this is a final result of servo motor speed control that we can adjust speed by code